Okay, hi all. So in today's video, we'll be talking about symmetric key distribution using symmetric encryption. So before we get into the details, let's just see what's the definition of this symmetric key distribution. When two parties share the same key, that is a symmetric key, that protects from access by others, the process between two parties that exchanges that key is called as symmetric key distribution. Where it's basically like, exchanging a key or a message between two parties or two people secretively. That is, uh, so that no other third person gets to know about the mm, message. So that is called as symmetric key distribution. So if we have like say let's have we have two parties say A and B that achieve the key distribution in various ways. So these way there are like various ways in which this key distribution can take place. That is, A, suppose there's a party A and B. A can select a key and physically deliver it to B. That is like A is going directly to B, physically giving the key directly to the person B. Or there's a third party that can select the key physically and deliver it to A and B. Two ways. Or we can have the other way where if A and B have previously and recently used a key, one party can transmit the new key to the other encrypted using the old key. Or we have the fourth way where A and B each have an encrypted connection to a third party C. And this C can deliver a key on the encrypted links to A and B. So these are the four different ways in which a key can be generated or distributed. Well, now let's talk about how these four ways are useful or what are the pros and cons of these. So first two ways, that is option one and two, calls for manual delivery of a key to the users. So in manual delivery of key is difficult in a wide area distributed system. So like if you have a wide area, like the area is too wide, then manually delivering the key would be very tiresome. It's very difficult to manage doing that. So let's just rule out option one and two. And then we have option three, that is, there is a possibility for either link encryption or end to end encryption. That's the case. But if an attacker ever succeeds in gaining access to one key, then all subsequent keys will be revealed. That is, in third case also, there is this con where if there is an attacker who can access to one of the keys, and then the subsequent keys and the information would be revealed. So I think option three can also be ruled out. We have the fourth option, which is widely used or adopted by everyone, which talks about we have seen like what which talks about uh, a third party C that is generating a key for both A and B, right? So let's talk more in detail about this fourth option. So in this scheme, key distribution center, that is what we're talking about, the third party, right? That is key distribution center is responsible for distributing keys to pairs of users. And these users can be hosts or processes, applications, anything as needed. So each user must share a unique key with the distribution center for purposes of key distribution. So this is the fourth option. So let's get to know about what is this key distribution center. The use of a key distribution center is based on the use of a hierarchy of keys. At the minimum, two levels of keys are used. Communication between end systems is encrypted using a temporary key, often referred to as a session key. Typically, the session key is used for the duration of a logical connection, such as a frame relay connection or transfer connection, and then discarded. So each session key is obtained from the key distribution center over the same networking facilities used for end user communication. Accordingly, session keys are transmitted in encrypted form using a master key that is shared by the key distribution center and an end system or the user. So this is how the fourth option or the key distribution center works. So there can be various scenarios that can take place during this key distribution at the center, right? There can be various ways in which this concept can be deployed. So let's talk in detail about these various ways. As you can see in the figure that is shown on the screen, we have the key distribution center on the top, that is the KDC, and then we have two parties, A and B, that where A, we chose him as an initiator, and then the responder. So there, as you can see, all these arrows, there are like various ways in which the key distribution can be processed, or these are the various steps. And then we even have the authentication steps. So if you can see, we have number like five different formulae or methods, you can say. So there are five different scenarios that can take place during this key distribution method, right? So let's just get into these five scenarios in detail. The scenario assumes that each user shares a unique master key with the key distribution center. So let us assume that user A wishes to establish a logical connection with user B and requires a one-time session key to protect the data transmitted over the connection. So user A has a master key, that is say K, known only to himself and the KDC. So user A will have a master key, say KA, and it's known only by itself and the key distribution center. And similarly, the same case is for user B also. Like the user B shares the master key KB in his case with the KDC. Now let us discuss about all the steps that will follow up. Step one, what happens? A issues a request to the KDC for a session key to protect a logical connection to B. So that's the case. Like first, A should request a key, that is the session key, to the KDC so that it can have a logical connection with B. That's what we have seen in this image where we have like see yeah authentication steps, right? So yeah, so first it will initiate a connection with B. A will initiate the connection with B. This is what we have shown you here in a formulated way. And then step two, the KDC responds with a message encrypted with K. Thus, A is the only one who can successfully read the message, and A knows it originated at the KDC. So what happened, right? In first case, A has requested KDC for a session key, and then KDC has replied to A with the uh, K as the key, right? And this is what happened between just A and KDC. So it's only between KDC and A, and only those two parties know what K is, that is the session key is about. Okay, so that's the step two. Step three is that A stores the session key for use in the upcoming session and forwards to B the information that originated at the KBC for B. So what now? Since A has the session key K, it will store it for the further use, and then it will forward the information that is originated at the KDC, which was supposedly should go to B. It will forward that message to B. So that's what we have shown you here in the formulated way. So next case, that is step four. What's happening? Using the newly minted session key for encryption, B sends a noise, that is N2 to A. So B will send back N2 to A using the session key that it is newly minted for encryption. So what step five is also using KS. A responds f of N2, where f is the function that performs some transformations on N2. So that's how encryption is taking place. That's how the key is being passed on to B, and then the information is passed on to B, which is taking place in a secured way. So this is about symmetric key distribution using symmetric encryption. In the next video, we'll talk about something more interesting topic. Thank you.